few of these, shall we? So I want to find the antiderivative, or the indefinite integral of this. So again, I look at this and I ask myself, is there a chain rule kind of thing that might help me figure out how to take the antiderivative of this? I look at the different pieces, and x squared minus 5 is in a square root. It's being multiplied by 2x. Clearly, I don't know how to take the antiderivative of this as it is.
Maybe try to turn it into a basic polynomial.
I know, that would be nice, but I can't. I can't
You
because
can't
that's a square root.
Can't distribute into it.
I can't distribute into it. Obviously, something raised to the 1/2, you can't like distribute the exponent. So I'm kind of stuck here.
But somebody's derivative is equal to that.
Yeah, yeah.
Yeah, and that's what we're trying to figure out.
And it's one I can figure out. So I'm going to use U-Substitution.
Okay.
So I'm looking at this. So when I start U-Substitution, I always think, okay, what will I have stand for U? So let's think, okay, if I want U to equal 2x, I'm always going to be taking the derivative of U. Well, the derivative of 2x is 2. Does that help me? No, 2 doesn't show up anywhere else in this problem. Let's try if U equals x squared minus 5. Okay, what's the derivative of x squared minus 5? Oh, well, that's 2x times dx. Oh, hey, there's a 2x, there's a dx. That's going to help me.
Yeah.
Now, some students say, well, why don't I let u equal the square root of x squared minus 5? Well, the square root of x squared minus 5,
well,
when I take that derivative, that's going to be this whole mess, blah, 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 blah. I mean, that doesn't help me at all, right?
No.
So you're always looking for a u that is part of your function that you're trying to find the antiderivative of, and whose derivative also helps you, illustrate, what's the word I'm looking, represent the other part of the function.
Yeah, sometimes I think about it in terms of I'm trying to change everything in the X world to the U world. Like I think about it as two different like parallel universes in a way.
Yeah.
And it's presented in the X world, and has some equivalent expression in the U world, and I have to account for all its bits and pieces.
We must have had the same calculus teacher, because I talked about the U world too. Isn't that funny?
Nice.
All right. Yeah, that's exactly right. That's exactly right. So let's go ahead and rewrite this. So it's in the U world. Can you see me over here?
Yep.
So if I'm instead, so now I'm just taking each piece. So this is going to be U, and I don't want to, I could say the square root of U, but I'm just going to use
Maybe we like to see the exponents.
Right.
Then there's the 2x.
So this piece, so the 2x dx, hey, that's my du.
Ah, a nice transfer.
Now, I'm going to just put, and I'm going to write it in this order just because that's how I'm used to seeing it. Some students write du times u to the 1/2. Well, that's okay, but this is how we're used to seeing it.
Right, you want to try to sandwich the expression in between the integral symbol and the d something.
Right.
They almost act as parentheses.
Exactly
like do the
right.
stuff in between them.
Exactly. This is saying take the integral with respect to u.
Yeah.
All right, well now this is a nice, simple,
basic polynomial.
straightforward thing, right?
Yeah,
So I'm going to add
1
1 to that, so 1/2 plus 2/2 is 3/2. I, of course, have to multiply by 2/3, so I don't have a coefficient, plus my c. All right, so I'm still in my u land here. But, of course, I want my
final answer
to be in terms of x. So now it's just a straight substitution. U is x squared minus 5 raised to the 3/2 plus c. And there we have it.
Very nice. And so that's an example of U-substitution working out perfectly.
It works out beautifully, where the derivative of u is exactly what you see in the original problem.
Which is nice, but fabricated in a way.
Yes.
So what if, we had a similar problem and that 2x was a 6x?
Yeah, all right.
Right? Should we attempt the same
Sure,
thing?
let's do that. So shall I just turn that into a 6x?
Yeah.
All right.
And let's see how
I
the
like that.
solution
That's
will
nice.
change.
Okay. So let's see how that is
Right,
going
we
to
have
change.
so a lot of the same issues. We can't turn it into a basic polynomial, right?
Right.
There's no special cases here. So we're going to attempt U-substitution.
Yeah,
Yeah.
okay, so I'm still
Same
using my
U.
same U.
The
Well,
der-
obviously the derivative is the same.
Right.
But now I'm saying, wait a minute, that's a 2x. I don't want a 2x, I want a 6x.
Ooh, I can think of a couple different ways to handle that at this point.
Yeah, so what I would say is, how can I turn a 2x into a 6x? Let's multiply
By 3.
by 3. Okay, I think I can do that as long as I
Do it to both sides.
do it to both
Still
sides.
algebra.
Nice algebra.
3
So
du's.
now 3 du equals 6x dx.
Huh,
So
you see
there
a
we
6x
go.
dx, you could change it into 3 du's.
Yeah, so boom, there's my integral. So I have my u to the 1/2, okay? And now my 3 du is going to have to take the place of that 6x dx. Now that's a little awkward.
Right?
I could put the 3 in front of the u, or you can really think, hey, that
Constant.
3 is not, it's a constant, right?
Right, you could factor constants out of an integral symbol and put them back in later.
Right, 'cause it's
just a constant multiplier
it's a
times
co-
the changing function.
Exactly, so it's a coefficient, really,
Yeah.
right?
And then add 1, divide.
There you go.
Put the
So
3
that
back
3 is
in.
hanging out, times, boom, 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 just as we did before, plus c. Same step as before, I'm going to substitute in my u. 3 times 2/3 now gives me a nice 2. And I'm substituting in my u plus c. And the beautiful thing about taking antiderivatives, they're so easy to check.
Yeah.
Just take the
Right,
derivative
the derivative of your answer.
of your answer and see if you
Should
get
be what you're
your
trying to integrate.
original. So let's do that. 3/2 times 2 is 3 times x squared minus 5 to the 1/2 times the derivative of x squared is 2x. 3 times that 2x gives you that 6x.
Right, right.
And there you are.
Beautiful.
Da, 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 da. Thanks, Mr. Paley. Ah, same problem, but now with another wrinkle. Who is that
All
in
right.
that screen?
Mr. Paley here. So we were thinking of, well, we just did a problem, right? And there was a 6 here, and at one point we got, the derivative of u step, where it was pretty easy to see that you just multiply by 3.
Yeah.
And then it kind of all worked out. So I was thinking, well, what if the coefficient was something where it's not so obvious to figure out what needs to get multiplied by? Let's see how this plays out. All right, I look at this, I can't turn it into a basic polynomial. Maybe the best I could do is raise this to the 1/2.
Beautiful.
And I cannot distribute into here, right? Partly
Fantastic.
because that's not really an x squared minus 5, it's an x squared minus 5 raised to some power that I can't really get a handle on. Okay, so I can't turn it into a basic polynomial, and we really only have 2 rules for integration. Basic polynomial, add 1, divide, or this kind of new process of U-substitution. Okay, so I'm going to attempt U-substitution, pick my U, and I like to think about it as the piece that would need the chain if I did my derivative.
Yeah.
Right? So that piece would then need the chain rule. So that'll make my U. My du is really with respect to x. In this case, it's 2x. dx. We'll write that. Cross multiply. So same d. Good. And here's where at the last step, when that was a 6, this was obvious. Multiply both sides by 3, and you get what you need. But here I'm jammed up a little bit in the sense that I personally, maybe some of you out there can do this, but I can't quickly think in my mind, what do I need to multiply 2 by to get 15/7? So there's another approach, and that is remembering, since this 15/7 is a coefficient or a constant multiplier to basically all of this. It's basically saying 15/7 times it all. I can factor it out of the integral symbol. Okay, so I have this 15/7 that I can then take out of the integral symbol, in which case the only thing left here is x, and you'll see why I'm writing it as a dotted line in a minute, but x dx, which I don't even want there, because I want them in the u world, but I clearly have u to the 1/2. So I notice this x dx, which I don't even want there, is showing up in my derivative sentence here. I can divide both sides by 2. I guess I already somehow have a division bar there. And it's telling me that 1/2 of a du is x dx. And now I have this x dx, which again I was writing as dotted just kind of to emphasize the point that they are there, but I don't want them there.
So you have to replace them with something.
So now the x dx is 1/2 of a du. So I could probably kind of rewrite all of this. I have the 15/7 there from before. The integral symbol, u to the 1/2. The x dx is now 1/2 of a du. And the 1/2 can come out and get multiplied by the 15/7, and it kind of takes care of itself.
Beautiful.
So I guess it was 15/14 before. And I could have multiplied by both sides, but
now
if
you know.
Right, if you just factor it out and divide away, you should.
Takes care of it. It does the algebra along with everything else. That's
Exactly.
nice.
I can now add one divide. That stays along. U to the add 1, which is really like 2/2. 3/2. Divide by 3/2, but really that's multiply by the reciprocal. And we end up with, let's clean this up a little bit.
Ooh, that works out nicely.
I would guess I would do something like this.
Sure. So you have 5/7.
5/7 stuff to the 3/2 plus c. And that stuff was...
Your original u. Dot, 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 dot.
And of course, you could always take its derivative
and make sure it works.
Okay. So the derivative of that stuff is multiply down,
13/14.
remain unchanged, subtract 1,
Times the derivative of the
stuff.
inside.
That's a 0. This is 30/14. I guess I can just rewrite that back as x square root.
30/14, I'm pretty sure is the same as our original 15/7.
And
our check is complete.
Our derivative is what we were trying to integrate.
Yeah.
Okay, so again, when you're doing this U-substitution process, what we're going to try to highlight for you is the 3 things that potentially could happen. Again, earlier in the video, we showed that it works out perfectly. And what I mean by that is the du, the derivative of u, accounts for all the other leftover pieces, and that happened earlier.
Right.
Okay, now we've shown a couple examples where we're off by a coefficient or just a multiplier number in front.
Right.
It's not a big deal because we could always factor it out and divide it away, or just think of what you need to multiply by to get it to work. Okay, so there's the 2 things. Perfectly works out, off by a constant or a coefficient. And there is one other possibility.
That's pretty tricky.
It gets a little weird, but again, it's the only process that will work, so we'll show you an example.
And that's when we're off by a
variable.